Okay, so in the previous clip then we were looking at the presence of this CH3 peak here, which remember would have an integration underneath it of 3, okay, corresponding to the presence of the 3 protons. And we were looking initially at low resolution spec. But what we've now tried to do is start to look at the high resolution spec and to see what will happen. And the high resolution takes into account, as we've said, the adjacent proton next door, or adjacent protons next door if there's more than one. And it is now possible that this peak, which had an energy or a magnetic field due to X, if we use the same terminology as we used in the previous ones, that what we now have is a situation whereby this proton in the adjacent position can either align itself with the magnetic field or it can align itself against the magnetic field. And what that then does is either push or pull the magnetic field to either a slightly higher reading or a slightly lower reading. The key thing is, though, that the average is still centered around the same point, but what we get is now this doublet situation, whereby one assignment is due to a proton spinning against the magnetic field. Don't need to assign which side is which, we're just arbitrarily doing it this way. But the other one is then due to the proton adjacent to the protons you are looking at. So remember, we are looking at the CH3 peak here. However, the shape of the peak is due to splitting of the peak due to protons on the adjacent carbon. But we get this doublet because of one going down and one going up situation. But key thing to remember is the area under the curve. It's a complicated curve. It's made up of 2 peaks, but we still regard the peak as being the one peak there in the low res spec and the collection of both peaks in the high res spec. But it's key to know that the area under the curve in both examples is the same, and the integration of that is still due to the presence of there being 3 protons in the doublet, as it would be called. Okay, so this is a doublet. Okay, so this is in high resolution spec. Okay, so it's still got an integration under the peak in total of 3 protons, as it still had a peak area of 3 protons in the low resolution. It's just that in low resolution we don't see this evidence of splitting. Okay, so low res you just see peaks due to chemical shift and integration, whereas when you go to high resolution you see doublets, you see what's called splitting patterns. Okay, you get splitting into, in this situation, a doublet due to the presence of there being a CH next door. And what we'll do is we'll look at the different situations that are possible in turn. It is possible to see doublets, triplets and quartets, but to say we'll look at those as we go.